Okay, so welcome back. So in this video, we're going to talk about some aspects of functions that you may recall. Okay, so one of the things that you've talked about in other classes that you might remember, but if we have a function is continuous, at x equals L. Okay? So f is a continuous function at a particular value L. Then we know f of x approaches f of L as x approaches L. Right? So we know that's true for any continuous function on an interval, right? If it's continuous at a particular value, then the limit of the function approaches f of L as x approaches L. Okay? Now, this also holds and applies for to sequences as well. So let's suppose that a sequence a sub n approaches L. Okay? So let's suppose that a sub n approaches L. So the limit of a sub n goes to L, right? That's what we've been doing, right? If that's true, right? And f of x is continuous, at L, then we know that the function of a sub n, of the nth term of the sequence, approaches f of L. Now, this property is often useful for finding the limits of complicated looking sequences, okay, for complicated sequences. So let's look at an example here. So what if we use the sequence, the square root of 5 plus, what was the one we were looking at before? 5 minus 3 over n squared. Now, we know that this, remember we did this, we had another sequence, a sub n, right? Where a sub n was 5 minus 3 over n squared, right? So and we know this, the limit of this is 5, right? We know that. Okay. We also know, if we look at the function f of x equal to 5 minus 3 over n squared, oh, excuse me, we know that function, f of x, oops, not n, is continuous. And it's continuous at x equals 5. Okay? So this fits the condition, right? So we have a sub n approaches L, right? So this a sub n, so in this case here, a sub n approaches 5, right? As x goes to infinity. F of x is continuous at L, so it is continuous at 5, right? Nothing happens out of the ordinary. It doesn't give us a negative number under the radical, so we're good. Okay, so it's continuous. So the conditions hold, so that means that f of a of n is the limit of f of a sub n is f of L. So what does that mean for this case? Well, if we take the limit, okay, if we take the limit as n, hold on a second. Yeah. So, in other words, this is a sub n, right? So the limit of f of a sub n as n approaches infinity of the square root of a sub n, right, is what? Because f of s, so here's the thing, because f of x is continuous, we can bring the limit inside the radical. Okay? Because the limit is based on, right, L is based on the limit. So this is the square root of the limit of n as n approaches infinity of a sub n. Well, what's the limit of this thing? Well, it's L, right? So it's just f of L, so it's the square root of 5. And that's the answer. So this allows us to be able to handle things like this easily by applying this result. And that's it. See you next time.